Hey everyone, welcome to Singularity Computers Client Build 7 Part 2. The name of this system is Dark Matter. At the end of the last video I installed the pump and reservoir, and I'm now going to move on to the graphics card water block installation. Before I do, just a quick look at the graphics card. So this is the EVGA GTX 660 Ti, and I'm going to do a separate review on this graphics card coming up. I'm also going to include performance and temperature results at the end of this build log. So it's a great looking graphics card. I like EVGA's designs. The stock cooler looks like it's made from carbon fiber almost. And this is an amazing little graphics card. You know, it runs cool and quiet. So without that stock cooler, this graphics card is incredibly short, just like the GTX 670. This PCB is actually so similar to the GTX 670 that you can install an EK GTX 670 water block onto it. So this is the EK FC670 GTX CSQ nickel plexi water block. It's a good looking block and the performance is going to be amazing because this graphics card hardly puts out any heat anyway. So I'm looking forward to seeing the temperature results and seeing how far I can push the overclocks. So I'm now installing the graphics card water block, and while I'm doing this I'm just going to talk about some things you need to watch out for when installing a graphics card water block for the first time. Now I actually recommend starting with a mid-range graphics card. Something like this is perfect. The short PCB is so easy to deal with. It's definitely a lot easier, a good place to start. Now the first thing to watch out for is when you're removing the stock cooler, be careful you don't bend the PCB. The thermal interface material, the TIM, creates a seal, and to break that seal, just twist the stock cooler side to side a little bit. Then it'll be a lot easier to remove. Then make sure you lay down the TIM in the right places. Check out the guide, the instructions for that. If you get that wrong, the graphics card could overheat in seconds. So it's critical. Sometimes there's different thicknesses of TIM, so watch out for that also. Then when you're laying down the water block, make sure you line it up the first time, because if you don't and you start pushing it around to line it up afterwards, it's going to push all the TIM all over the place and you're going to end up with bad contact, bad temperatures. The graphics card could even overheat and it could damage it. So after that, you need to, when you're tightening the screws, start in the middle, work your way out, and keep an eye on the PCB. Make sure it doesn't bend or buckle, because if you've made a mistake with the TIM and you've put it in the wrong places, that's what can happen. The PCB will massively bend and that can kill the graphics card. So that's just some things to watch out for. So there it is, a GTX 670 water block on a GTX 660 Ti. And while you're taking a quick look around this config, I'm going to answer the question that came up the most on the previous video. And it was about the graphics being a bit underpowered in this build compared to the rest of the components. Well, it's because the 660 Ti is actually temporary. Every build has a budget, well, most builds, and the component that we decided to go a little bit less on was the graphics. I had people saying in the comments, why didn't I go a bit less on, you know, the motherboard or the power supply or the water cooling system and go a bit more on the graphics? Well, that's because I knew this system was going to get a graphics card upgrade, and I wanted to make that upgrade easy. So, for example, if I had have gone less on the water cooling system, it would have meant rebuilding half the water cooling system just so that you can upgrade the graphics. The same goes for the motherboard. You know, if it was the power supply, it would mean redoing all of the wiring. All you have to do to this system to upgrade the graphics is just throw in a couple more graphics cards, change around a little bit of the tubing, and I mean, this system could handle 3 high-end graphics cards without a problem. You wouldn't have to upgrade a thing. The graphics card is now installed, and there's no doubt it's dwarfed by the rest of the components, but once the tubing and wiring is connected to it, it will blend in. It won't look too bad at all. Again, the graphics card is temporary, and also this system is getting a factory overclock, so the performance out of that graphics card will be substantial. Now, before I move on with starting on the water cooling loop, another thing I've done at this point is installed the case fans. So I'm using Noise Blocker Black Silent Pro PK2s for the case fans to match up with the Noise Blocker Black Silent Pro PLPS that I've used on both of the radiators. So I'm installing one at the front here of the hard drive cage. I'm not going to put one down there because, as you can see, it's almost half blocked off by the radiator and fans down there. So one at the front of the hard drive cage, also one at the back of the hard drive cage. That's going to bring plenty of air in through the front. And I also have one at the back, and it's actually an intake, which is why I've used a Silverstone 140mm magnetic dust filter on the back of the case. Now, there's two things that you need to think about when configuring the fans in your case: convection and also positive pressure. I'm not going to talk too much about this because I've talked about it many times before. I actually talked about it recently in my water cooling guide, but I'm now going to talk about the thermal design in this case. So I have two fans bringing air in to the case through the hard drive cage. The two fans at the bottom here are bringing air in. This fan is also bringing air in. So that's basically, one fan there, one at the back. So that's 4 fans bringing air into the build. There's actually 5, but there's 2 in a row here. So then there's 3 fans taking air out of the top of the case. So that is definitely positive pressure, and as long as all of the intakes are dust filtered, it's an excellent and highly effective method of dust prevention. And if you take a look at this build, all of the intakes are dust filtered. Now for the specifications of the case fans: 1200 RPM, 1.27mm H2O, 54.7 CFM, and 22.4 decibels. Okay, I'm now moving on to tubing up. Before I do, I obviously need to install the fittings. I'm now going to talk about how to figure out exactly the fittings you need for your build. Now, first of all, you obviously need to figure out how complex you want to go with your fittings. If you're just using barbs or compression fittings, then it's easy. You just count out how many fittings you need, and it's basically 2 fittings per component. But if you're going more complicated and using angle fittings and crystal link and all of that, it does become a lot more difficult, and there is a certain amount of guesswork that's involved. I get so many people asking me for an exact list of the fittings I use in my builds. People want me to put it in my video descriptions and all of that. Now, I always list almost every component I use in my builds in my videos. So if you want to know, just watch the video. I'm not going to go writing out massive lists of components. Seriously, it would be pages long sometimes, in my video descriptions. So what you can do, if you want to figure out exactly the fittings you need to figure out your component order and your tubing routing. You need to know the exact layout of your water cooling loop. This is where the guesswork comes in. You've figured out your component order, your tubing routing. Now you need to know the angles you want your tubing to be on. And it's basically visualization. You need to be able to picture it in your head and figure out the basic angles that those tubes are going to be on. The distance between the fittings and the angles. And if you think about it enough, you can get very close to the fittings that you need. Obviously the first time you're going to make some mistakes, but as time goes on, you get better and better at it, and eventually you'll be spot on. But the thing is, you need to allow for mistakes. So just get a few more fittings than you need. So basically, if you need 4 90-degree dual rotaries, get 6. And that will allow for slight changes in configuration. If you need to change the config, it will allow for different angles that you haven't taken into account. If you really get stuck, then I suggest just getting a whole bunch of 90-degree dual rotaries, because they are the most versatile fitting. They can be used for almost anything in a water cooling loop. And I mean, they can be used as a 90, as a 45. They have 2 rotating pieces that rotate 360 degrees. I use them to get offsets for all kinds of different things. So that's what I recommend. Now, someone made a comment the other day and it got me thinking. This is going to sound a bit out of context. They said there's only one way of building a loop anyway. And I know not everyone is going to think that, but that seriously limits creativity. So I thought I'd do a little exercise. I'm going to do it in this build, and I'll do it again coming up when I get the chance. I'm going to build this loop twice in 2 completely different ways. So this is config 1, and as you can see, I've used mostly tubing except for one piece of crystal link down the back of the pump there, and I've gone for the cleanest possible aesthetics with tubing. So I've used a lot of angle fittings to get the shortest distances between components, and straight lines with the tubing. So actually the only reason some of the tubing is curved is because it was coiled, so it has a natural curve. That actually comes out in a few days as long as you pull the tubing tight. But when I look at this, I really feel like there's something missing. For all of the fittings that I've put into this, the aesthetics still aren't that great. And anyway, I'll go over the component order now and the fittings I've used. So I've gone from the pump to the CPU water block with a single rotary 90 into a dual rotary 90, and then I've gone up to the 360mm radiator with a dual rotary 90 and another dual rotary 90, out of the 360 just with a straight compression fitting, into the graphics card water block with a 90-degree single, out with a 90-degree single, down into the 5-way multi F block. Before it I have a 90-degree single rotary, and connecting it to the 240 I have a mini D plug. There I'm using a bits power tap for the drainage system. Then coming up the back I'm using a 90-degree dual rotary, 45-degree single rotary. Then I have the bits power crystal link configuration with two multi-link fittings and a 90-degree single rotary back into the pump. So now for a look at config 2. Now in this config I've made some substantial changes. Not just the visual ones, there's a lot of changes which I'm now going to cover. So first of all, I've used a lot more crystal link this time, and because I've used a lot more crystal link, it's meant I've had to use a lot more fittings, because the two adjacent fittings in a crystal link config have to be perfectly straight, otherwise you'll get leaks. Whereas with tubing, they don't have to be perfectly straight, there can still be a slight bend in the tubing. Now I've actually reversed the flow in this config. So I go first of all through the graphics card water block and then the CPU water block. And some of you might be some of you are going to say you're going to get horrible temperatures doing that. But that's not the case, because component order doesn't matter. It makes an absolutely minuscule difference to temperatures. In a loop like this, it won't make any difference at all, because the water cooling loop is already overkill for these components. There's more than enough radiator capacity. The pump is more than powerful enough. So anyway, some other things that I've changed is the tubing routing. I've changed it slightly. So you can see that I've gone straight across from the CPU water block to the top of the res, whereas before that tube went all the way down from the CPU water block to the pump top. I've also swapped the tubes down the bottom here. So before it came down from the graphics card to the 240 at the front, and then the crystal link was over the back. So you can see what I've done there anyway. Now there is another benefit with this config. With this particular pump and reservoir configuration, it takes a long time to fill a loop if you connect up to the pump top like I had it before. And that's because the reservoir, when doing that, is obviously not part of the flow of the loop. It's just acting as a filler. It's like a T-line. For those of you that know what a T-line is, it takes a long time to fill a loop with a T-line, because the fluid is carrying the air past a tiny little hole, and you can see that with this configuration. The inlet down into the pump top from the res is 1/4 of an inch, and the fluid is racing past that hole with the air, and the air has to slowly come up through that little hole into the res, whereas this way the res is part of the flow of the loop. So the fluid is carrying the air into the res, and it has a lot more area in which to rise up to the top of the res. So basically the initial config, it would have taken about half an hour to fill the loop and a couple of days to get all the air and micro bubbles out. This way it'll take minutes to fill the loop and probably hours for all of the air and micro bubbles to come out. Okay, I'm going to give you another look at the wiring once it's complete, but it's just about complete, and there is a lot of wiring here, and I'm really happy with how clean I've managed to get it. So you can see the 8-pin EPS and 4-pin ATX down here. Whole bunch of fan wires mixed in with it, all of the front panel connectors across the bottom. This is the two 6-pin PCIe going to the graphics card. It's actually two 8-pin, but I've tucked two of the pins back there. All of the front panel goes up through here, mixes in with the 24-pin motherboard power, whole heap of fan wires. So this is all the front panel wiring up here. There's the 3 fans coming down from the top rad. They connect up there to the quad PWM splitter. So there's all the SATA data. A couple of them go up through there. The rest go into the hard drives and SSD. And this was a massive mess of wiring in here that I've cleaned right up. There's a quad SATA power splitter from Molex. But anyway, all I need to still do is connect up the pump, which is now connected up here for the leak testing. That just tucks down there, and there's a spare Molex here for these 2 fans, which are the 2 fans on the hard drive cage, so they're just case fans. Other than that, I still need to hook up the lighting and also the power for the optical and also the hot swap. It's now time to fill the loop, and as you can see, I have everything set up ready to go. All of my precautions are in place, so I have tissues around the build wherever there could be a leak, towels on standby, the drainage system is hooked up ready to go, and the pump is hooked up to my Phobia external 90-watt power supply. It's easy to take these precautions. It takes minutes to set them up, but it can take hours, even days, to clean up spilled coolant and replace dead components. So as I always say, take every precaution you can against leaks. Now you might have noticed that I'm about to use a different coolant color than I was originally planning for this build. So originally I was planning to go with the dark matter theme, but I'm going to talk more about that shortly. Right now I'm just about to hit the power button, and watch how quickly the res empties, because this is a D5 pump with only really 4 components in this loop, the 2 radiators and the 2 water blocks. What I built this loop for was the future upgrades, which I've already mentioned, the future graphics config upgrade, and this loop will easily handle that. So anyway, I was planning on using Mayhem's Pastel Pure Black combined with Master Clear UV Blue tubing. But basically it didn't turn out as I wanted it to. So in the res, the coolant had a kind of green look to it, very slightly, and the tubing has a blanket UV effect. So instead of having the blue glint that I wanted, it just all goes blue and you can't even see through it anymore. It just has a blanket effect. You know, some other UV tubing I've used in the past doesn't really have that blanket effect. It's more of a glint. I guess it depends on the brightness of your UV lighting, all of that. A UV effect, a good one, is difficult to get. You need to have the right lighting, it needs to be in the right places, all of that. But basically it wasn't perfect, so I decided to go with Mayhem's X1 Blood Red. And it's a very dark blood red, actually getting close to black. And if it's not, I'm going to darken it up and add a bit of blue dye to it. You can't add too much because then it will start to go purple, so you have to be careful. The blue dye, the Mayhem's blue dye, is also very, very strong. But anyway, you can see there how dark it is. And actually at this point that's full circulation, and there's less than a litre in the loop. There's about 750 mils. So not a massive loop, and it was very, very quick to fill. It literally took a bit over 5 minutes to fill this loop. So, and that's because of the config changes that I've already mentioned, the reservoir being actually part of the flow of the loop. Now some of you might be thinking that the build doesn't fit the name or the theme anymore, but actually the name, I give my builds code names so that when I refer back to them, people know what I'm talking about. If I just give them a number, it's a lot more difficult for people to remember. This is so that I can refer back to them in future videos. And actually, the build is still going to have a very dark and stealthy color scheme. If it was a themed build, it would be modded, painted, all of that. So anyway, I'm actually going to have to leave this part of the build log here. In the next part of the build log, I'm going to focus on giving you a good look around the finished product and covering the performance and temperature results. That sums up this video. Thanks for watching. Please subscribe, like and favorite if you want to see more.